In the previous video, having discussed mean absolute error, right, which we denoted by delta A bar, we tried to understand how to find out the magnitude of error while we are measuring any physical quantity. In that case, we had taken a very simple situation that we were measuring only one physical quantity. Right? But there are times when we have more than one physical quantities. Let me take an example. Let us say we are trying to measure the semi-perimeter of a rectangular shape, semi-perimeter. Right? That would be given by length plus breadth. Say for example, I have a rectangle shape. This is the length, this is the breadth. Length plus breadth will give me semi-perimeter. Now the question is, what is the error in the measurement of semi-perimeter? Quite obviously, since semi-perimeter depends upon length and breadth, the error that creeps in while we are measuring length and while we are measuring B would affect the error in the semi-perimeter. What we want to do in this video is understand what is the relationship between error of the length and error of breadth and its impact on the error in semi-perimeter. And we'll take a very general case. Let us say we have a physical quantity Z which is given by two other physical quantities X plus Y. Right? As I said, I want to find out what is the error in Z if I know the errors in X and Y. So if I know the errors in X and Y, X can be written as X plus minus delta X, where delta X is the error in measurement of X, plus Y plus minus delta Y, where again delta Y is the error in the measurement of Y. Right? This will give me Z plus minus delta Z, right? Where delta Z is the error in measurement of Z. My focus of attention is what is this? What is the value of delta Z in terms of the error in X and Y? If I open these brackets, I'll get X plus Y plus minus delta X plus minus delta Y. This is Z plus delta Z plus minus, of course. This X plus Y will be equal to Z, right? X plus Y, because as we've seen over here, X plus Y is Z. So X plus Y is Z. This Z and this Z will get cancelled, and therefore I'll get plus minus delta Z is equal to plus minus delta X plus minus delta Y. Okay? So now I have a relationship between the error in the semi-perimeter in terms of the error in length and in terms of breadth. For example, if I think of this as semi-perimeter and this as length and breadth. Now, what would be the maximum value of delta Z? Right? What would be the max? The maximum value would be when both delta X and delta Y have positive sign. Right? If one of them is negative, then the magnitude would decrease. So when both of them have a positive sign, that's where we will get the maximum value of delta Z. So this will give me plus delta X plus delta Y. So what is this? This is the maximum error in Z. Right? The error could be less than this, but this is the maximum error that would creep into delta Z. The same thing would happen if we had a relation like Z is equal to X minus Y. Right? Nothing would change. I would still come to this conclusion because again we have got plus and minus. Let us do that quickly. So Z can be written as Z plus minus delta Z is equal to X plus minus delta X minus Y plus minus delta Y. If I open this bracket, I'll get Z plus minus delta Z is equal to X minus Y plus minus delta X minus plus delta Y. Right? Now X minus Y is Z, so this Z and this Z will cancel out each other, so I'll get plus minus delta Z is equal to plus minus delta X minus plus delta Y. Again, what will be the maximum value of delta Z? That we'll get the maximum value when both delta X and delta Y are positive. Therefore, I'll get delta Z is equal to delta X plus delta Y. So again, I come back to the same conclusion. So from this, I conclude that if we have a physical quantity, or we have two physical quantities, which on adding give us another physical quantity, the errors also add up. Right? So the error in X plus the error in Y will give us error in the physical quantity Z. To end the video, let me take a very simple example. Let us say the length that we took over here is given by 10 plus minus 0.1 centimeter and breadth is 5 plus minus 0.1 centimeter. So I know the two physical quantities over here and their errors in them, 0.1 centimeter, 0.1 centimeter. So what would be the error in semi-perimeter? So Z will be equal to L plus B, therefore Z will be equal to 10 plus 5 is equal to 15, and delta Z would be equal to delta X plus delta Y is equal to 0.1 plus 0.1 is equal to 0.2 centimeter, and therefore I would write down the value of Z as Z plus minus delta Z. So I would write this as 15 plus minus 0.2 centimeter. Right? So what we can see over here, that the errors in length and breadth were 0.1, but the error in Z, which is dependent upon L and B in this case, becomes 0.2. So the errors have got added up, and the possibility of error in measurement of Z increases because of the individual errors in length and breadth. This would be same for both addition and subtraction. Okay, so we have looked at propagation of error, how error propagates when a particular physical quantity depends upon two other physical quantities, and there is addition or subtraction between them. In the next video, we will look at Z is equal to X multiplied by Y and Z is equal to X divided by Y. So how does the error propagate when you have multiplication or division of two physical quantities, or more than two physical quantities? That's what we will discuss in the next video. Thank you.